Welcome to Push and Pop, which is our new name now. I'm your I'm your host Shafu, and today's episode is with Alex from Recon. We had Alex on the podcast before, one of my favorite episodes, to be honest with you. They just released a new extension, which Alex is gonna show us and talk about. So Alex, yeah, good to have you back, man.
Yeah, thank you for having me, Shafu. We have quite a bunch of updates, and yeah, we effectively released this extension with the goal of making it easier for people to write invariant tests.
Awesome. Yeah, Alex has some slides to show us for the intro. But yeah, I remember from our first episode there was quite a lot of boilerplate to set up everything, which the extension probably makes a lot easier, right?
Yeah, the key point is we have developed a workflow which we call the Chimera framework, which fundamentally connects Foundry with other tools such as Echidna, Medusa, and Almos. And
Mm,
so it makes it so that we're going to start by writing Foundry tests, which are a lot easier to write. And then we're going to test those same tests with other tools, which are typically stateful fuzzers, which means that instead of just trying one of the functions for a specific test, they try combinations of them and
mm,
they keep the history of what they're trying so that over time they also improve. These tools are, in my opinion, uh, the best at doing that, but their developer experience is really poor. And so that's why we try to get you back to Foundry, which is a lot better for quick iteration. And so that's kind of what you'll see me. You'll see me have some of this boilerplate, which is handled by the extension. And then we're going to get Foundry to compile. And then from there, we can run these more advanced tools to hopefully find some bugs.
sick. Sounds amazing. You want to start sharing your slides and we get into it?
Amazing. So to make a long story short, I've been doing security research full time for maybe 3 years at this point. I used to be a judge. I used to be a developer at Badger, and that's where we started using invariant tests. We met Antonio Vigiano, and we collaborated, and that's how Recon was born. Off of Recon, now we have three full-time invariant testing engineers. We work with Centrifuge, Badger, Liquidity, and Corn, and others. And fundamentally, we're literally open sourcing our playbook because it has helped us prevent very massive exploits, and we believe more people should do it. So you can find a ton of our work on GitHub. We also have, if you check any tool, HEVM, Halmos, Medusa, or Echidna, we have a list of bug that we report to them because we use the tools very extensively. And the way our engagements work is we have to deal with the boilerplate, which is the setup. We then want to reach coverage, which means that the tools are reaching interesting combinations. We then want to write properties to actually write our assertions so that we can verify something. And then from there, we will iterate, which simply means we're going to keep assessing coverage and writing new properties. And so um, this is what the Chimera framework boilerplate looks like. We have a file called setup, which is for our deployment. We have a file called critic to foundry, which is the file in which we'll write foundry tests. We then have the critic tester, which is instead the file we'll use to run other tools. And then the rest of the files, before, after, properties, and target functions are for to effectively to manage complexity. It's just a form of software engineering where we'll put all of the different function calls in the target functions. We will put all of our tests in the properties, and we will put any ghost variable, which is a set of variables that we store to track something over time. We'll put it in this before after file. And obviously, we can also extend this a bit. And the we basically have this extension that makes it a lot simpler, which is what I'm going to use today. And the reason why is because over the last year and a half, we've identified quite a lot of bugs that would have resulted in hundreds of millions of dollars in damage. And we also use these same techniques to prevent $20 million of exploits against smart contracts that were actually deployed on chain.
Mm. Nice. That's really cool. Awesome. So, cool. So we're actually gonna use the extension now, right? We're gonna use it on Sablear's Flow repo. Okay,
Yeah.
so yeah, walk us through it step by step.
Yeah, fundamentally, the prerequisites to be able to follow along will be to have installed Foundry. Hopefully,
Mm.
that's I don't have to show that. And then
Yeah.
you will need to install one of the two fuzzers by Trail of Bits. One of them is called Medusa, which you can get at github.com/critic/Medusa, or you can get Echidna at critic/Echidna. The installations at this point are very easy. Last time we spoke, I told you to install some random binaries from the web. That's no longer the case. There's a brew command to install Echidna, and I believe Medusa also has a brew command, and there's also a go install command. So you can literally build the binaries locally. And at this point, all of the installations is very easy. So the last piece is the Recon extension, which you can get from the Visual Studio Code marketplace. We are recon-fuzz. We have an alert for any phishing, but definitely make sure you're installing the right extension. And if you don't want to use the compiled version, you can build it yourself from our own repo at recon-fuzz/recon-extension. The extension is fully open source. If you find any issue, please file it here. And we plan on updating it over time to support more fuzzers, especially Almos, which has committed to this type of testing that we're going to show.
Nice. Alex, could you maybe close down the this little window so I don't have to see myself all the time?
Okay.
Thanks.
Awesome. Do you still see my screen?
Yes, yes.
Amazing. All right. So yeah, at this point, I basically have the Sablier Labs /flow repo, which seems to be a repository for tracking flows of contracts. It basically allows, I guess it will allow to, in this case, it says literally that it's a debt tracking protocol. So we effectively have a stream that instead of estimating values that are being owed, it will estimate debts. So
Mm,
it's pretty similar to a vesting contract. And invariant testing is actually very powerful when it comes to rounding errors and economic attacks. And so hopefully I get to show some of the cool stuff on that. But to follow along, you will just clone Flow. For the sake of time, I already have it. And so I didn't do anything so I can really match the experience of somebody getting started. First of all, once you have the Recon extensions, you'll see that you have these options. You should also see these two buttons to run Echidna and Medusa. If you don't have Echidna or Medusa installed, you will still see the buttons, but they're going to break. So just make sure you can run these tools. There are probably simpler tutorials than this, but this will show you a professional workflow that, again, found many experts. So at this point, you'll see that once I open my extension, I have these two new files. One is called settings, which basically specifies a few of the config off of the Recon extension. And then we have recon.json, which is going to do something really cool really soon. So at this point, I'm just going to build. And blah, blah, blah. We probably need Open Zeppelin. So I guess I'll yarn first, and then we're going to build off of that. So this is just the Foundry, and that's the beauty of our Chimera framework. We're not gonna do anything that you can't write in Foundry. We're simply gonna run other tools because we deem them more optimized for this workflow. But fundamentally, you could use our extension and then run invariant test in Foundry as well. We are 100% compatible with that. So at this point, we have three issues. One of them is going to be the setup. We're going to go over that first. The second one is going to be writing properties, which is the most difficult part. And then the other one is going to be coverage, which we'll see in a moment. And so writing properties is something that we can't really teach in a few minutes. But fundamentally, it's a mixture of having already dealt with protocols like these. And then the other aspect is going to be performing manual analysis on the specific contract so that you can think of specific properties or specific invariants, and then you can write a quick test to help you verify that. So that's a bit difficult to teach, but now that we have built the project, you can see up here in the contract section that we have a bunch of contracts. And so because we are testing the Sabler flow and it seems like it doesn't have any particular amount of dependencies, we can simply click on Sabler flow, and that's gonna open up this option that says separated. Separated means that instead of putting everything into the target functions, it's actually going to create a separate target function contract called Sabler flow targets, which is just a way to manage complexity. So that's what I'm going to do. And then by opening the toggle, you'll see that I have a bunch of options here. And these options are going to be tied to the specific type of testing that I want to do. I can have normal mode, fail mode, or catch mode. And then I can have the call being performed by an actor or by an admin. This is going to sound very overwhelming, but we're going to show it in a moment. So for now, I'm just going to keep everything in the default. I'm going to click on scaffold. The extension is going to detect whether I have the dependencies, and it's going to install them for you through the Foundry installation process. And then from there, it's going to generate a few contracts of boilerplate by creating a new folder called Recon, and then creating the files that I mentioned before, after, critic tester, critic to foundry, property setup, and target functions. And lastly, it's going to separate the target functions into these components called the admin targets, the doomsday targets, the manager targets, and the Sabler flow targets. And so this can feel a bit overwhelming. What do you think about this so far, Shafu?
Yeah, so okay, so the targets admin, where's the admin targets, doomsday targets coming from? What's that exactly?
Yeah, so fundamentally, we have these Sabler flow targets, and the extension is adding this code lens up here that makes it so that if I click any of these modes, it's going to refactor the test to be in catch mode, meaning it fails if we revert, or fail mode, which always fails just to check for coverage, or normal mode. But it also gives us the option to change the actor, and you can see that all of our functions have this modifier called as actor, and all as actor does, it's going to prank the current actor to make it so that we can simulate having more than one actor inside of Solidity, instead of relying on something external, which is how you will do it on Certora, or how other fuzzers will do it. And so when I click on as admin, you'll see that the modifier changes. However, by convention, if you scaffold the extension with admin targets, the extension will automatically put them in your admin targets file, because we want to signal that these are not as frequent operations as the ones from the contract targets, which you would expect every user will use, whereas the admin targets will only be called by the admin account.
Okay. Okay, so admin targets are only for admin functions, basically like only owner functions.
Yes.
Okay, what are doomsday targets?
Doomsday targets are something that we put by default, and they're based on the idea that there are some tests that you will want to perform without performing storage changes or state changes. That's because once you start tracking with before after, meaning you start tracking state in some way, that tracking can get very complex and it can be a pain in the ass to manage. So the way you will do a doomsday test will be something like this: function do doomsday operation, and then you will do some sort of a call here, and then you will use the modifier called stateless to make it so that no matter what type of storage changes happen in this function, they will all be reverted. And that's because of a convention in invariant testing. The convention is that a test doesn't fail if it reverts. It only fails if you assert false. And so what would
Hmm.
happen here if we assert false is that the tool will actually catch the assertion failure first, even though the handler is not changing the state. And so we will still be able to detect an assertion failure, but we wouldn't have to deal with the mess that this test could create. So for example, if you had all of your actors try to withdraw, which you will do by, loop over actors and then each actors withdraw, you probably don't want to change your state that much. And so you will probably use this stateless uh, modifier. And then, but you will probably still want to do the test so that you can check if in that scenario something bad can happen.
Okay, well, where's the doomsday? Why did you call it doomsday? Where's that coming from?
Yeah, this is due to how we call our properties. There are many ways to classify them. We took that from the work done at Sartora, where they talk about a few, and me and Antonio created a couple of them. I created the Doomsday properties, and Antonio created the Dust properties. And so, to make a long story short, if we're going to write a few properties, which is probably a good thing to talk about because we're going to do that later. But
Yeah.
the long story short is you would have some sort of perhaps a before after property, which we tend to call a stateful fuzz property. And a stateful fuzz property is basically what you will write in your normal Foundry fuzz test. You basically do something and you check if it works. An example could be if I deposit X amounts, my balance increases by X. Does this make sense so far?
Yeah.
Another example, and the before after property is a subset of properties that are called state changing properties, where basically we just look at changes in the state. And the specific type of interesting properties that are tied to state changing will be global state properties. An example could be if the system is insolvent, if the users are solvent or insolvent, whether a user is in a specific state, which could be the fact that they're liquidatable, or whether they have a debt that is owed to them, or whether they owe a debt. And so these will be global properties, and they tend to be extremely valuable once you get your suite to a certain point. And of the yeah, off of this idea of a few of these types of properties, we effectively coined the term doomsday property for something that should never happen.
Mm.
And so what you will do in those type of tests is you will test for scenarios that if that scenario was triggered, you would have to have a emergency response or a war room. And
Mm.
so those type of tests tend to be very destructive because let's say you try to have everybody withdraw or everybody's liquidated or every account becomes insolvent. And so they tend to mess up the other tests. And so that's why we typically put this stateless modifier to avoid creating too much of a mess while also testing for these very low likelihood edge cases.
Interesting. Okay, so we have the doomsday, we have the manager, we have the admin, and we have the flow contract itself.
Exactly. And so what this does for us is we basically have created what we call the target functions. These are the functions that we will call with Foundry as well as with other tools to explore the state. And so our next step is going to be to figure out the whether the code actually compiles. That's because of unsolved issues that are unsolved by many teams, including the Foundry team, of figuring out how to deploy a contract in the intended way, the way the developer intended. And so
Mm.
all our extension does is it scaffolds the targets, it scaffolds the template, and then it gives you more stuff that I'll talk about later. But the compilation is still something that is unsolved as of today. And so most likely when I do forge build, we'll see some issue. Okay?
Yeah.
So in this case, we see that we're missing console2
Mm.
from this node module dependency. So this is a bit of an unexpected issue. This may be an issue with the remappings. Let's see what we have. We have node modules, forge, std. So in this case, maybe this repo doesn't use console2. So we'll probably just to we'll probably just investigate this by perhaps changing this to console, or we can also just grab console off of the test.sol, which should help us get to a step further. In this case, we see the same issue that ForgeSTD doesn't have tests. So I'm gonna have to see, this is really not an issue with the extension, but also an issue with how the imports are done with this repo. So we'll just investigate them for a bit. I guess I need to grab Forge STD.
Yeah, Paul is a big fan of node modules inside Foundry projects, which
So we do have Forge STD. And then we probably have to see what the remappings looks like. Remappings for Forge STD is just Forge STD. So the issue is that our remappings are going to be slightly different. So we probably just need to do this. Forge STD. So I just need to look at the folder one more time. We're going to have src. And then we should have test.sol. So forge std slash test.sol definitely is not gonna be it. We need to try node module forge std slash test.sol, but we did add src, so I'm a bit confused.
I think it's another file, right? Foundry asserts, foundry asserts.sol. Yeah. There, you need to
Okay,
put
so
in,
this
yeah.
remapping is causes issues to us as well. So let's see if I can just grab I guess I'm not gonna, I could just grab the Forge STD off of this, but most likely this is gonna mess us up as well. So this is the, Dizzy, one of the maintainers of Foundry will hopefully see this video. This is the real problem with many of the Foundry repos is these nested dependencies. It just makes it very difficult to handle this type of stuff. And then we see we have this issue with the types not being imported. So most likely we just need to grab the type, which seems to be, let's see, we're gonna go in Sabler Flow, we're gonna see create, and we're gonna try and grab this specific type, which comes off of this repo. So at this point, we're literally just fixing a few of the imports, which come from trying to have a fully genericized template. And then we finally got to the compilation issue that I mentioned, which is typically having to set up the actual contract. So we'll just have to grab the constructor. We see the initial admin and then a NFT descriptor. I'm assuming this descriptor is not going to be used particularly. So we'll just probably try putting address this and address this for now, and then we'll deal with the consequences. At this point, I can talk about some of the ideas that come with our own boilerplate are called managers. We have an actor manager and an asset manager. The actor manager allows us to keep track of who the actors are. And by default, the only actor is address this, but you can add more. And what this does is that whenever you use our templates, and obviously you have set them up the way the extension does with this as actor modifier, we basically have a manager target that allows you to switch actor. So the fuzzer can just call this function and change who we're gonna prank from. And then all you have to do to add a new actor will be calling this function underscore add actor. So you just do add actor address OX Bob, let's say. And now we effectively have two accounts that can perform all the calls. One of them is address this, which will also be the admin. And then the other one is going to be Bob, which is not going to have permissions for acting as an admin. Does this make sense?
Yeah, it does. One question, couldn't you get like the constructor arguments at least and show that?
Yeah, we could get the arguments here, for example. We could also set them to the default, which would be address 0. I think we can get it to compile fairly easily. The
Mm.
problem you will still run into is that is something a bit sketchier, which we're gonna look into in a moment. But it's that once the code compiles, you have to use the coverage report to figure out how well you're doing. Unless you look at the coverage report, you're literally not going to know whether the code is actually working. So to give you an example, I'm going to do forge build and hopefully it's going to work. I don't expect it to fail. But let's see, we have this implicit description error. So maybe we just need to grab an interface here for the INFT descriptor. So we'll just do this off of src slash interfaces and we'll cast ourselves to be this. So we're basically just brute forcing this to work because now we get to the more difficult part because obviously if all you had to do was this, I think most people will find this fairly reasonable. The
Mm.
problem is twofold, is that our current deployment implies a set of states that we can explore, meaning that like the fact that I've addressed this and this as the NFT descriptor may cause some reverts that we don't know about or may cause some issues. And so the this is why we put an entire phase of our engagements for coverage, because coverage can be trivial and maybe it will be, but it can also be very difficult. So to explain what coverage is, the best way is just to show what our next step is. I'm going to grab the extension again, and you can see that below the Recon cockpit, below the scaffold option, we have the option to run a fuzzer. I typically want to run Echidna most of the time, so that's what I'm going to do. And we can see that we have different modes for the tool. And exploration mode means that we're going to skip any type of test, which we didn't write, by the way, but we're going to skip them. And then we can set the test limit to a number that is fairly big. And what's going to happen is the extension is going to trigger Echidna to run. The command is actually pretty annoying to write, but it will be something like this: echidna dot dash dash contract critic tester with the config, format, workers, and a test limit. So it's a pretty annoying command to remember. Medusa is a lot leaner, but fundamentally, not only is the extension going to run the tool, but it's also going to parse the logs off of the tool. And so what it's going to do is it's going to automatically track its progress. It's going to create a report for us that tells us which properties were tested, in this case, just the target functions. And then it's going to tell us which properties were broken. And then off of the broken properties, we will also get repros, which I'm going to show later once we get to some more meaningful point. The downside of running a tool like Echidna, you can see it here, is that it actually takes quite a while to run the tool. And
Mm.
so it can be problematic to, have to wait for something like that. So I don't know if the extension timed out. Maybe there was a memory issue. We're gonna try running it again.
Okay. How long does it typically take?
Yeah, the issue with running Echidna versus Foundry is that it has to rerun Foundry, grab the AST, then it's going to run Slither, and then it's
Mm.
going to run. And so it typically takes a lot longer than Foundry because Foundry will always rebuild off of a cached version. And you also don't have the overhead of having to rerun Foundry off of another tool. So yeah, in the like our currently the ideal I mean, you can see how this is really not ideal because we have to wait. And this is why we basically started with the Chimera framework, because even though Echidna, is such a clunky, annoying tool to wait for, right? You have to wait 4 minutes for it to even start. It is just so much better than Foundry's fuzzing. I guess the extension is dying, unfortunately. We'll have to figure out what's going on. But basically, it, what we really did with with this tooling is we made it so that if the code will compile in Foundry, which as you can see is super fast, then it will compile with Echidna. So I'm going to run Echidna off of the outside of the extension and demo some other features. But basically, we think the trade-off is worth it because of what Echidna can do that Foundry cannot. And
Mm.
so to enumerate a few of the things, the first one is by default, Echidna will not trigger a failure on a revert. It ignores that. So
Mm.
it's set up to be used for trying stuff without caring, without having to overclamp. And then the second reason why Echidna is better is that it has these the coverage report by default, which I'm gonna show in a moment. But that means that anytime Echidna is done, you get an additional artifact that helps you evaluate the work you've done. And the coverage is key because through the coverage you can figure out which state transitions are being tested and which are not. And so that's the second problem with Foundry that Echidna solves. And then the third one, which is completely underexplored, I'm gonna sound like a like a preacher, but like nobody uses this mode called optimization mode. And as far as I can tell, optimization mode is something that you literally can't have with Foundry. You can't have with SMT tooling. Even the Sortora tool, in theory, could do it, but you can't do it. Halmos cannot do it, Control cannot do it, and so that's the only option that you have if you want to run optimization mode is going to be using Echidna. So yeah, I'm seeing that there's something off with the memory in the extension. I'm not super sure what's up. I'll just demo a couple of the other features of it, and we'll probably fix those this bug next week. But as you can see, it is it is taking a while for us to get to compilation and to get to see what it does, and that's really the trade-off. Is that you don't want to always wait for this, which is why we run them in the cloud, right? I can just know that it's gonna work with Foundry, then set in a reasonable amount of tests, like 100 million or 1 billion tests, and then just run them in the cloud over the weekend, and then on Monday I can come back and see whether it works. And another thing that Echidna and Medusa do that Foundry doesn't do is called corpus reuse, which means that now that the tool is running, you'll see that it's generating all these lines, and that's because it's literally trying new things and saving them. And what this means is that once we actually have run the tool and we have a corpus, the tool is smart enough to reuse it and retry all the interesting combinations so that over time, a shorter run is actually as good as a longer run. So to give you a real example of why I started Recon back in at the end of 2023 with Antonio, we had Echidna running on a repository for the eBTC protocol. So I'm pretty sure it's on eBTC protocol slash eBTC. And so there's an old version of our technology called Perly Echidna Tester. And it's all way clunkier than what it is now. But this suite, which is for a Liquidity v1 fork, will take like literally a day and 10 hours before it will start breaking properties.
Mm.
Like you had to wait 2 days for you to test things. And it was still worth it for us because we didn't have another option.
Mm.
But off of corpus reuse, meaning you just take the same folder, you can see it here. There's going to be this Echidna folder with all of these files, text files, which basically contain a bunch of ABI encoded data. But because of this, you would actually be able to rerun a 2 days test in probably less than an hour and possibly even in 5 minutes. So the amount of time you save once you start reusing stuff is massive. But you can I can definitely see I showed you how unfriendly it is to get into this. And so that has been really the thing plaguing this technique because the technique works. It's extremely valuable. I use it all the time, and I'm the biggest advocate for it. But it fundamentally requires kind of this almost this leap of faith in using it for a day or two. And then once you start breaking properties, that's when you will never go back.
Mm. That's interesting because it just takes so long. Not many people take that leap of faith. It's like, yeah, that makes sense.
Exactly. And the key issue we try to solve off of using our extension is that because like we can let the tool run, right? And then while the tool runs, I can go in the critic to foundry, and if I believe that some of my targets are not gonna work, I could test them myself. So obviously we can see that some of these are fairly complex, but we can see, for example, Sablier flow pause. And so what I can do, I can go here and basically just pause a random stream. And now I'm saying I'm going to run a foundry test that performs the call to this handler in the same way that this fuzzer tool is doing it. And so now I can debug it by running the test, which is, let's see, critic to foundry. And in running it, I can see that this is reverting because most likely the flow doesn't exist, and so
Mm.
I'm unable to use this. But basically, what this is saying, and obviously I could try it with other parameters, but this is telling me that the pause function is reverting because I didn't do something else. And so, off of doing this, we should be able to debug other interesting aspects of the code base. So, at this point, we can basically stop the tool, which I'm seeing feel like VS Code is having a bug, so maybe I'm gonna have an issue in trying to stop it. But let's see if it stops by itself, because obviously once it runs the sufficient amount, it should. And off of it stopping, it will generate a report that is actually human readable. And our extension has ways to compress it to make it even more convenient. So let's see if maybe the command D is gonna work. So maybe I'm gonna have to restart the VS Code, but that means we have to rerun Echidna, which is gonna be a bit annoying, but I guess we'll just have to do it.
Yeah. Oh no, it's saving,
Oh, there
saving.
we go. Save the
Nice.
last second. And so yeah, this is also why you wanna run this on a stronger machine. This is a MacBook Air,
Mm.
but yeah, the generally speaking, we would okay. But so it's interesting how Echidna is showing us exactly what I mentioned, where the this test, which is called Doomsday Operation, which was in the Doomsday targets, we can see that even though it's stateless, meaning it wouldn't perform any state changes to the other contracts or itself, it's still the exception is still caught, the assertion failure is still caught, meaning that we will get a repro. Uh, and famously, you can use this again for more complicated tests. So we're waiting for the corpus to be saved, and after that we should get the coverage report, which we are going to look into. But fundamentally, this is basically part one and part two of any engagement when you have to deal with invariant testing. The other part, which we can look into a bit, is going to be writing the properties. So the first thing that we can do is go into the code and check a bit how it works. So we see that for each stream ID, there's this covered depth off, which is basically checking for some sort of a total depth. So this is the amount of depth covered by the stream balance. And so what this leads me, and it's I've looked at this code base for quite literally less than a few minutes, but the what this leads me to think is that we could test for some global property that will be tied to the amount of depth that is being covered. So an example will be, we will probably have to find a function to cover the depth. I don't know if it exists, but off of that function, we could store the amount of depth that we try to repay, and then we will verify that this value matches that, or we will verify that this value never surpasses the entirety of the debt that we owe, which would imply that there's some sort of an insolvency in the code. By the way, Paul is famously a foundry testing maxi. So if we ever find a bug in Sabler code, you'll actually know because he's gonna start using Echidna. So we have to. It's something we'll eventually try. But yeah, the as you can see, we have the corpus, the coverage, etc. So we'll go back to the properties in a moment. And yeah, the coverage report looks like this. And basically, we're going to have all of the files. So this is going to be somewhat of an overwhelming experience. You can see that there's like hundreds of files that we don't care about. But at the same time, this also has the files that we do. And so what we did, I'm going to restart VS Code to hopefully get the extension to come back. So what we did is we have two toolings for Echidna. One of them is called the coverage statistics. This gives you statistics for every file and it shows you the lines that are not being hit. From my experience, this is not how I do it, but when we open source the package, it was very well received, and so we added it. So if this is how you work, you can grab Sabler Flow, for example, and you should be able to see the lines that are covered versus the lines that are not. Whereas the way I like to work is this button right here, open in browser, which basically cleans up the coverage report to only the files in SRC, making it so that we have this cleaned file, which is a lot easier to use because it only has just a few files. So in our case, the file we want to check is Sabler Flow. So we can see how depletion time off is never called because it's a view function. We're seeing all these view functions not being called. That's because whenever we're dealing with coverage, we typically don't do that. And then we're seeing user-facing non-constant functions. So this adjust rate per second is not being hit, create is not being hit, deposit is not being hit. So we're seeing that there's quite a lot of lines that are really not working, right? Everything looks red, right?
Yeah.
So this is why invariant testing is so difficult. It's because if everything is red, it means that our tool is literally just throwing a bunch of randomness, a bunch of gibberish, and nothing is sticking. It's not actually testing anything. So we could spend, weeks writing properties, but we will be unable to test anything because we're not actually exploring any meaningful state. And so this means that we have to go back to our target functions. So we will move here to the target functions and investigate why they're not working. And so we've been stuck at this point for so long that what we would do is we wouldn't just run the tool and cross our fingers and hope. What we will do instead is we will go to the critic to foundry and we will try and explore a few of these functions. So I'm just gonna start probably with the first one. It's probably gonna be create. So I'm gonna just literally grab the Sabler Flow target, which is called Sabler Flow create. And I'm gonna grab a few of these inputs so I don't have to constantly tap back and forth. But basically, I'm gonna put get actor, which means the current actor as the sender. I'm gonna put some random address as the recipient. I will have to use this UDX21, which we have imported up here because we had the issue before. Or I guess it's part of the Sabrier flow, so maybe we don't need to explicitly import it. So I guess I'll just import it in this way. And so I'm gonna grab this and just wrap it at a rate per second of, let's say, 100. I'm then gonna grab a token. This actually introduces a new common issue with DeFi especially, which is dealing with tokens, which I'll show you how we fix. But fundamentally, for now, I don't have a token, so I'm just gonna put address 0. And then I'm gonna say that this is not transferable because I don't know what it is, and it's probably gonna make things even more complicated. But so fundamentally, all I did is I created the most naive call to this function, right?
Mm. Yeah.
And now I'm gonna run it and run it in Foundry because, let's see, it seems like I should have typed wrap instead of warp. But basically, I'm just gonna run it with the goal of seeing where things break. Seems like we need to import an IRC20 as well. So let's do that. And most likely this line will fail because there's no token. And so we're seeing a revert though that doesn't really tell us much. And this is basically why working with Echidna alone was effectively impossible. Like imagine having a tool that takes 8 minutes to tell you that it reverted with no explanation, right?
Yeah, yeah,
It
yeah,
will be
yeah,
done. But
yeah.
now we can debug with Foundry at least, so we can probably figure something out. We can see that we're doing a call to create, then we're calling prevent delegate call, and lastly we're calling decimals on address 0. If we want to figure out if there's a causal relation, we will just change the value and we will most likely find a match. I would expect this to match with address 1, 2, 3. So this means that without a token, our testing suite is literally worthless. Okay?
Mm. Mm.
So obviously this is a very common issue that we've had for years now. And that's why we have another manager called the asset manager that makes it so that we can manage tokens. Not only we can manage them, we can even create them. There's this function called new asset that we can call in setup to basically set an asset with 8 decimals, an asset with 18, an asset with 6. And all I did here is, and you'll see it in the traces if we check them up here, but we're basically deploying new tokens with those decimals and adding them to a list of tokens that can be accessed through get assets. And the current enabled token, which will be the last one you add here, would actually be available through get asset. So this means that off of these 3 lines of code, we now have made our testing suite tens, if not thousands of times more complicated, even though that's all we wrote, because we can now have 3 different tokens being used. And the way you would pass this input will be as simple as typing get asset, which should be of type address. So I think you can literally just do this. And now we solved the issue of the silent revert because the token exists and we actually get a stream to work,
Yes,
right? So
nice.
now we tested this with these inputs. There are, this is where things can get very complicated. So stop me the second they do. But
Yeah.
basically, we are under the idea that you don't want to overclamp your handlers, overclamp them. And so you could basically fix all of these functions by grabbing each of them. So let's go to Saber Flow. I will grab the function called create, and then I will go here and I will just do get asset, right?
Mm.
So this is how you will do it. And if I'm doing a suite in 1 day, this is what I'm going to do. If I'm doing a suite in 1 week and I need to find crits, I will hard code it this way. But if you wanna do a coding convention of keeping all of the handlers as the highest possible level of combination, so we don't clamp them, and then you just do a subset, that what you will do is you will grab this handler, you will put it up here in the custom target functions, and now by doing this, we can actually create a handler that is going to be a subset of these handlers because we have less inputs. And by doing this, we basically reach coverage faster without having to lose on the possibility of having the other generic handler. Not only that, but if you put your handlers here, the extension will protect them. Whereas if you put them down here, the extension will always override them anytime you use the contract scaffolding tool.
Okay. Interesting. So the get asset gets the latest defined token, right? Always.
It actually it doesn't, because we have these manager targets, which by default comes with switch asset that
Hmm.
makes it so that the fuzzer gets the last one you put. But then the fuzzer can also switch the asset to possibly break one of the tokens
Mm.
for you.
I see. I see. That's how you test on different assets.
Yeah. In
Okay.
the default setup, we also have add new asset, meaning that the fuzzer can also deploy a new token. Uh, Many times professionally, I don't put this, but we leave it here so you can use it. And we also have ways to mint and approve if it's necessary. Although you could also just do like a loop here and approve every actor here. So that's
Mm.
kind of a bit of a niche thing. But yeah, our goal is to make it so that you will reach coverage faster. So I'm now creating a clamped handler. I'm gonna just put get actor because obviously I'm gonna always do the call. Why wouldn't I? And then the recipient could be any recipient. So I'm gonna let Echidna do this. Then the rate per second probably is best left alone. And then the token instead is gonna become get asset. So I only use the current token. And then the transferable is something that we can probably let Medusa, Echidna figure out for now. And so I wrote this function that has no modifiers. It only calls the internal target functions because these target functions that we scaffold with the extension have a way to handle the actors. They will have a way to handle ghost variables. They will do a bunch of stuff. Like all of my assertions will go here. Whereas the clamped handler is just a shortcut to give less inputs for the fuzzer to find. Okay?
Yep.
And so now we can test that by going back to critic to foundry. We will basically call this clamped version. So we need just these three inputs.
Clamped is a great name for this, by the way. Never heard that.
Yeah, we call it that. You can probably just do get actors. Like let's say I'm just gonna get the next actor for the recipient. I'm gonna wrap 100 because it doesn't have a specific meaning to me. And now I can just try the clamped version, which is gonna be equivalent to the unclamped version. But this will make it a bit easier for the fuzzer to get stuff done. So we've seen that we're missing a casting. That's my bad. And this is why you always wanna fix it with um, Foundry first, because Foundry is going to give you all of the feedback very quickly. But now we have the coverage, it is working. So now we go back to the tool, meaning we're going to grab the Echidna command and we're going to run it again. And what's happening is Echidna will obviously take its time, please, there are a couple of flags to make it faster, but this is something that can be fixed only by the Echidna developers. But now Echidna that is, going to take its time or whatever, it's going to be stronger because of all of these files, all of the work we already did is going to be tried again because we didn't change the key handlers. So all of our work is building onto itself. And then it's also going to use these shortcuts to be a bit more efficient. And so this is where things get somewhat tedious. It is a bit tedious because we would have to figure this out for all of the remaining handlers, right?
Mm.
So it's definitely not trivial. It's definitely not that simple. However, you can note how we tried our best to make it so that anytime it deals with a actor, we give you a utility to make it faster. Anytime we're dealing with a token, we give you a token implementation and a way to handle that. And so what's really left is all of the protocol specific complexity, because obviously we can't know that you use UD21x18, uh, and we can't give you a manager for it, also because of the limitations of Solidity. Because if Solidity had generics, we could actually have a generic manager, and then you would simply write your own managers. And anytime there's an input like this, we would use it in a templatized way.
Mm.
So that's something that could happen in the future if either we get a preprocessor for Solidity or if Solidity becomes more generic. However, as of today, you'll find that some of these batch functions, like multicall or transient operations, those are really difficult to deal with the fuzzer. Benjamin from Trail of Bits did a talk about it at FuzzFest, a live we did, and yeah, it's just where the tool is. However, what you'll see once you start adding a few of these clamping and a few of these guided aspects is that you really start to explore a lot of interesting states. And once you do, then breaking properties becomes something that you can do. And then once you break properties, which we haven't even looked at that yet, but once you break properties, that's when you can look into something like optimization mode to ask the tool, such as Echidna, to give you the maximum value that will break that property. So instead of just breaking the property, let's say we have an insolvency here and we break it by 1 unit, which is what Foundry will do, it just gives you a random value. We can then rerun Echidna in optimization mode with a quick test, and that test will actually give us the maximum theoretical value, which is a lot more valuable than just knowing uh, we're just getting some random value. And obviously this is a fuzzer, so it's trying stuff, so it could in theory miss the actual theoretical maximum, but in practice it tends to be very good at giving you something that you can then build some manual POC off of.
Mm. Cool. I love that workflow of using Foundry first and then Echidna. That's that makes it so much easier.
Yeah, and then the other part is that because this is 100% compatible with Foundry, once you break a property, we give you tools. The extension is exploding today, but we give you tools to scrape those properties into Foundry repros. I'm gonna show that off of the website. I don't know if we have any broken property, but basically, yeah, for now we don't. But basically, once we do, you will basically uh, just run it through a scraper, which is open source, and off of that scraper, you will get a new test that you can put in your critic to Foundry, meaning that the professional tool like Echidna, which is it's literally like using a uh, it's almost like using like a laser cannon to do something. So it's only good at breaking stuff and everything else is a mess. But it gives us a repro, and then you can go and use that repro in Foundry to debug the broken property or debug the bug and figure out what you can do from there. Meaning that our what we show in all of these videos is typically just a couple of lines of Foundry and then a bunch of Echidna. But in practice, I have a fuzzer that is running that I started yesterday. It's gonna run until Monday. On Monday, I'm just gonna get a repro from Echidna and I'm gonna debug it in Foundry to figure out the root cause. And
Mm.
so that's a lot closer to what the real workflow is that once you have to arm this cannon, right? You have to figure out how to make it work. But then once you do, it basically improves to a point where you still have to deal with its clunkiness, but you always go back to Foundry as much as possible because Foundry gives you such a faster iterative cycle.
Really cool, man. Really cool.
So let me see if I can quickly show you very, very interesting. It seems like we're having some issue here as well. So I'm gonna start running Echidna from another terminal. But let me just try and break a couple of properties to show that aspect. So we're gonna probably have to restart again. Very unfortunate. But basically, all of our targets should have the code length to be able to toggle them, which is provided by the extension. I think this code compiles, so and yeah, I guess the way we'll do it is this: we have our clamped handler, and let's say we want to verify that this actually goes through, which is the first type of broken properties you will write. We call them canary properties, but this is basically a canary for this function. And so off of it, we basically can run Echidna. So I'm just gonna see the, I guess I'm already in the folder. So I'm just gonna run Echidna real quick in the flow folder. And basically, we're just gonna run it and get a repro off of the broken ball.
Yeah.
And obviously, for something this simple, the the repro will basically be just calling it and running the function with those inputs, which are inputs that don't cause a crash. The way we would write such a canary property in a professional environment will look a little closer to something like this, where we will do bool has, or literally you can grab the name and just call it canary. So you can probably do bool canary underscore, and then you will set the canary to true here. And then lastly, we will write a function, which I'll put it here, but you will probably put it somewhere else. But we would call it something like canary check on this. And you will then assert false, which is, we use T for true, but basically we assert that this is true. And obviously, once this becomes true, we negate it. So the moment this gets toggled to true, this property breaks. And so this will be our canary to know whether the line was hit without causing the assertion failure in line, because causing an assertion failure in line will still revert the transaction, just like because of how the EVM works. The fuzzer is really just executing the contracts in the same way you would if you deploy them. And so this allows us to know whether something has happened without having to, cause more assertion failures. An alternative way will be to add a log, but having the log will force us to always go back to the coverage report, and so it tends to be a lot slower than using this type of canary properties. If we had a lot more time and budget, we would write something like this, where it's like, Recon underscore canary, and then maybe the name. And we will probably convert this into a macro that automatically generates all of this stuff. I think it's fairly achievable, but we're somewhat limited by the amount of engineers. But there's a world of stuff that obviously that can be improved for this tooling. But the thing that keeps us using it is that at its core it actually works. So in spite of all of the extra hoops you have to jump through, it really helps you build safer code, obviously, because you can fuzz all of your functions when you're building a contract. And then it also helps you identify hard to find bugs once people deploy them. So the main limitation is just needing to do this quickly, right? Like if you ask me to break a property by tomorrow, I don't know if it can be done. Maybe somebody can do it, or you're probably better off just doing minor review. But if instead you have the time, you'll notice how this gives you compounding benefits, because once you set it up, it keeps going. Once it's run a few times, as you can see, it tries more stuff. And so it basically is something that, like, all the payoff is closer to the end, whereas the beginning is very rough. And we've tried to make it a bit easier by adding, the extension, all of the frameworks, and also the ability to quickly look at the coverage report in a compressed way, which makes it so that it's just a bit nicer than if you had to deal with the raw version of these tools.
Nice, man. Nice, really cool. Maybe it's a good spot to stop here. I think we're over 1 hour at this point. But yeah, no, super cool. So yeah, go check out the extension, install the extension. It's all open source, right? Recon
Yeah,
extension,
it's
yeah.
GPL2. It's open source and it must remain in the open source as well.
Nice. So yeah, if you run into any issues, go on GitHub, create a new issue, and I'm sure Alex is gonna figure it out. Anything else that you check out? You sent me some documentation as well, which I'm gonna link in the description down below. The Recon website. Oh, the book. Yeah, exactly. That's really good docs. Anything else, Alex, that you should check out?
Yeah, I mean, if you don't want to have to code this and you're a protocol developer, you can talk to us again at recon.xyz. That's what we do. We have free engineers do this full time. And then I also do audits, and we're building a team for auditing as well. But definitely, if you are doing this professionally, feel free to reach out. We're happy to talk and help. And yeah, for sure, the I would say if you watch this, go try it. Go perhaps on a simpler project on just a few lines, go try and fuzz those. And I think you'll see why this can be really powerful, because now once you have fuzzing on your side, anytime you miss something through your manual review, you have a second pair of eyes in the fuzzer
Mm,
checking again to make sure that what you thought or the way you thought the system worked is the way it actually works.
amazing. Thank you, Alex. It's always a pleasure to have you on, man.
Yeah, thank you, Shafu, for having me. And yeah, I guess I'll see you on part 3.
Nice. See you guys. Take care. Bye bye. Really cool stuff.